as we work this here, the emphasis is not going to be on graphing, okay? We're going to get to parts where the graph is blank and it's going to be absolute value function, quadratic function, different functions. Today, the emphasis is not on the graphing part. We'll go over some of that and how we got that graph, but the emphasis is going to be on the key features of the functions, the domain, the range, the XY intercept, where it's increasing, decreasing, where it's positive, negative, okay? So don't get stressed about the graphing part. There'll be other sections where we're deep diving the graphing, okay? So don't let that part stress you at all, okay? So first right here, we got domain and range. Obviously it's on there. What is the domain?
X.
The X values, the range is the Y values. What comes first in the alphabet, D or R?
D.
D. What comes first in the alphabet, X or Y?
X.
X. D goes with the X. R goes with the Y. Okay? So, with the domain and range, we have two different notations that we can write our answers, our solutions, okay? Or our domain and range in a different, as we go, writing all this. Set builder notation and interval notation. Raise your hand if you remember ever doing that. Okay, cool. So, you'll generally see more interval notation, but set builder notation is also pretty common there, okay? As you can see, the definitions are on there. Some keys to the notation. We'll have brackets, parentheses, and braces, okay? The brackets and the parentheses will be used in interval notation, okay? That'll be used in interval notation. All right, the braces will be in the set builder notation. So, when we're talking about when we use brackets and parentheses in the interval notation, I went with our basic number line here just to show you how it's used. Remember on our number line, if we have an open circle around a number, what's that mean?
It's like not exactly on it.
It's not included in the solution, right? 1.1 would be included in the solution, but 1 would not be, right?
It's a greater than 1 and then less than or equal to 4.
Perfect. Yep. That's exactly right. The closed circle is telling us that 4 is what?
It included.
Included in the solution, right? 4 would be a solution. Okay? So the parentheses and the brackets, they mean the same thing. The parentheses would tell me that 1 is not included in the solution. The bracket would tell me 4 is included in the solution. Okay? So same meaning there. And then is it Deacon? What's your name again?
Matthew.
No.
Oh, Gavin.
Gavin. Why do I always want to call you Deacon? I'm sorry. Gavin. All right, I'm going to get his name. Like Gavin said, this will mean X is greater than 1, X is less than or equal to 4. Okay, when getting the set builder notation. So, if you look at this first example here, our interval notation, 3 and 4, okay? The brackets are telling me both 3 and 4 are included in the solution, okay? Then we'll have our set builder notation, okay? So, for our set builder notation, the way that reads, I'm going to do it up here on the board. This is when we use our brace. All right, that reads as, we have our brace. All variables x such that x is greater than or equal to 3, x is less than or equal to 4. Whenever we have inequalities, we always read from the variable. X is greater than or equal to 3. X is less than or equal to 4. Okay? We always read from the variable with inequalities. Next example, now we have parentheses. Okay? So that is telling me 3 is not included in the solution. 4 is included in the solution. In set builder notation, the way we'd write this, brace, all variables x such that x is greater than 3, x is less than or equal to 4. Okay.
So that solid line just means such that.
All right. So here, as you look through these, the only difference as we go through here is we now have infinity, okay? Infinity will always have parentheses, okay? Infinity will never have a bracket. You'll never put a bracket around infinity, okay? Infinity goes on forever. You will always have parentheses around infinities, okay? Same rules apply. So when you're doing a set builder notation, you'll have greater than or less than with infinities. Now, if you get all real numbers on the set builder notation, I'm okay with you writing that all real numbers symbol, okay? That carries on a little too long. I shouldn't have the tail there, but I do the down R and then go back up. But anyways, okay. So then I also drew up here just for like visual interpretation, 3 to infinity, 3 to negative infinity, okay? All right, again, remember this next part. The emphasis is not on actually graphing it. This part here, the emphasis is on domain and range. So we have our quadratic. It's going to be a parabola, x squared minus 3. So don't worry about all this. Okay. Our graph will be at 0, negative 3, 1.750, negative 1.750. Okay. Make sure we get this graph down. Okay. All right, the key points there. That's just so you have that graph up there. Okay. All right, so our domain is the what values?
X.
The x values, right? Domain is the x values. Looking at this graph, how many x values does that function cover? Huh?
All of them.
All of them, right? Keeps widening forever, right? It's going to keep going and going and going. It's going to keep going and going and going. So that domain will be all real numbers. Okay. So, and when we say it covers all of them, you could take any x value on the x-axis. You could take 2, 3, 4, 5, 6, 7, 8, 9, 10, plug it into this function, and it would give you the y value on the graph, okay? You could take any x value on the x-axis, plug it in, and it would give you the y value on the graph, right? So for example, if you took 5, plugged in 5, 5 squared is 25, minus 3 gives us 22. So that graph would be, there'd be a point on that graph at 5, 22, okay? Now, opposite of that, now doing the range, this graph covers what y values?
All of them greater than negative 3.
All of them greater than negative 3. So from negative 3 to infinity, including negative 3, I'm about to change that to a bracket. It's not a parentheses. Okay, so from negative 3 to infinity is our range. If I plugged in negative 3, all right, that would work, okay? Plug in negative 3, that would give us 0, 0, negative 3, okay? Now if you plugged in negative 4, negative 5, negative 6, negative 7, that would not work, okay? There would be no solution because it's not on the graph, okay? So that range would be from negative 3 to infinity.
I have a question.
Next example here on domain and range. All right. Any of y'all recognize that function? What kind of function is that?
Absolute value.
Absolute value function. When we graph absolute value functions, what do they look like?
Right. Straight lines. Isn't it?
Kind of straight lines. I mean,
Oh, it's the V.
it's the V. Good. Right? It's a V. Why is it going to be a V? Why? Anybody? Well, because if you plug in a negative, it's going to give you a positive. So it's going to mirror both sides, right? If you drew an axis of symmetry, the x values, if you plug in the x values, it's going to be the same distance as you go apart. They're mirrors or reflections of each other. So here, we'll get into this. This is just our parent function shifted right for. Let me just get this graph on here. Okay. The absolute value is just, that transformation is just shifted right for. So just get that graph down. Those points are at 0, 4, 8, 4, which is off the graph, and 4, 0. Okay. So what would the domain be here?
It would be infinite.
Infinite, all real numbers, right? Is going right and left forever. That graph is going right and left forever. It will cover every single x value. Okay. Now for our range here, we're looking at the y values. Common mistake is they will use the x value when talking about the range here, but we're not even looking at that x value. We're doing the range. We're looking at the y value. What would the range be?
All positive numbers, right?
Plus
Zero.
0.
Over 0, right? It'd be from 0 to infinity. That range would be from 0 to infinity. All right, look at this next example. Get the graph. So those points are going to be at, that vertex is at 1.5, 4.5. And those x-intercepts are at 0, 0, and 3, 0. Okay? When you get that graph down. The vertex is at 1.5, 4.5. And the x-intercepts are at 0, 0, 3, 0. So here, what would the domain be?
Infinite.
Infinite again, all real numbers. Cover every single x value. All right. Now our range will be flipped here, okay, because our function is going down. So our range would be from, any guesses?
4.5 below.
4.5 to negative infinity, but you never write negative infinity second, okay? You always go from negative infinity to that number. So it'll be negative infinity to 4.5. Negative infinity to 4.5. Okay? And that goes with everything we do here when we get into positivity, negativity, increasing, decreasing. You'll never write negative infinity second. Negative infinity will always be first. Okay? All right. Next part, we get into our x and y intercepts. All right, so x-intercept is where the function crosses the x-axis, right? Pretty simple. X-intercepts are also known as zeros of a function. Circle that zeros. Circle those zeros. Okay. What are the zeros?
The x-intercepts.
The x-intercepts. What are the x-intercepts?
Zeros.
Yep. What are the zeros?
X-intercepts.
What's another name for x-intercepts?
Zeros.
Good. So if I have an assessment and it says find the zeros of the function, are you going to come up to my desk and go, Coach Burrs, what are the zeros?
No.
You like my kid voice? Yeah. No, you're not going to come up to me and ask that, right? Because you're going to know the zeros are the
X-intercepts.
x-intercepts. Now, y-intercept doesn't have another word for it like x-intercepts. But remember, the y-intercept is where the function crosses the y-axis, okay? So, now, if we don't have a graph, we don't have a visual, we can always find the x and y intercepts when given a function by, if we're finding the x, we plug in a 0 for y. Okay. We have an x, we plug in 0 for y. Okay. Plug in 0 for y. And then we would just solve for the variable x. We need to isolate that x. Add 3. Absolute value of x equals 3. So what would x equal here? Good. -3 and 3. Both. So our x-intercepts would be 3, 0, -3, 0. And then to find our y-intercept, we plug 0 in for x. So if I do that there, plug 0 in for x, what's the absolute value of 0? 0. So y equals -3. So I have my intercepts. G of x equals 4 minus x squared. That's the same thing as y equals 4 minus x squared. Exact same thing. All right, so should have gotten that the x-intercepts are at 2, 0, -2, 0, and the y-intercept is at 0, 4. Any questions there? Okay. All right, next part here, we're identifying positive and negative intervals. So, simply put, the function is positive when it is above the x-axis. It is negative below the x-axis. All right, so a major key here, where a lot of people get tripped up, is that when we're writing our intervals, we're using the x values of the function, okay, of the ordered pairs. We're using the x values. So here, as you graph this, all right, we have a quadratic. The vertex is going to be at 0, 9. And then we're going to have points at -3, 0, and 3, 0. -3, 0, and 3, 0. Okay. So, like I said earlier, it's going to be positive above the x-axis. What I highlighted in red, it is going to be negative below the x-axis, okay? Another key here is when you're reading the positivity and the negativity, you're reading it from left to right, like you're reading a book, okay? You're reading it from left to right. So, dealing with the x values, I know it's part of the reason why it's positive is because it's above the x-axis, which that's positive y values, right? But when we write the positive and negativity, we're dealing with the x-axis, the x values. So this is positive from negative infinity to negative 3, and it's positive from 3 to infinity. Okay? It is positive from negative infinity to negative 3, and from 3 to infinity. Okay? Negative infinity to negative 3, and from 3 to infinity. It is negative from negative 3 to 3. It is negative from negative 3 to 3. I did those. I couldn't get it to fit in the blank, so did it like that. Red is the positive, blue is the negative. Then we're dealing with negativity, or positivity, negativity, increasing, decreasing. It's always going to be parentheses, okay? Always parentheses. We will never have brackets when we're dealing with positivity and negativity. Okay. So again, the blue is the negative intervals. The red is the positive. Couldn't get that to fit. So. Lo siento. Next example is a little easier to see because it's linear. Okay. 2x plus 10, the y-intercept's at 10. I had to do that in intervals of 2 to get it on the graph. And then it's going to cross the x-axis at negative 5, 0. Okay? It's going to cross the x-axis at negative 5, 0. So, and that's what's important with positivity and negativity, which I actually... Okay. So... Again, it's negative below the x-axis. So it's negative from negative infinity to negative 5. Talking about the x values. Negative infinity to negative 5. And then it's positive from 0 to infinity. A lot of people want to say, I'm sorry, I just messed up. And then it's positive from negative 5 to infinity. I went dyslexic there for a second. All right. It is negative from negative infinity to negative 5. And then it's positive from negative 5 to infinity there. Okay. Next part here. We're going to talk about our functions increasing and decreasing. It's increasing when the graph goes up from left to right. It is decreasing when the graph goes down from left to right. Okay? So for what intervals are following functions increasing, decreasing? So again, left to right, right? Like you're reading a book. So this first function, we have an absolute value function. All right, it's going to be a shift up 2, and the negative in front of the absolute value is a reflection down. Okay, if you remember any of that at all, be a reflection down. So it's our parent function reflected, and then up 2. Okay. So what I ended up doing here too, like forget these. Don't write that. Forget these arrows. Okay, we're still dealing with the x values. Okay? We're still dealing with the x values. Don't even look at... I erased those arrows off, okay? Because don't let those arrows giving you a direction confuse you, okay? We're reading left to right, right? We're reading left to right. So it's increasing from negative infinity to 0. All right? Again, common mistake people want to say here, it's increasing from negative infinity to 2, but we're dealing with the x values. and then it's going to be decreasing from 0 to infinity. Right. And 2, another confusing part too is it gets a little backwards, right? It's decreasing, but it's going to infinity, right? It's going down, but it's going to positive x values, right? It's going down, but going towards positive x values. So it's decreasing, but it's going to infinity, okay? It's increasing, but it's coming from negative values, 0. That actually makes more sense, but okay.
Wait. Why wouldn't it be like negative infinity to 2?
So that's a very common mistake. That's what people want to say because the vertex is at 0, 2, right? But when we're writing it, we're dealing with all the x values. So that x value is 0 there. Okay. That will be like on an assessment, there will be people who say that it's increasing from negative infinity to 2. That will be a very common mistake. Yeah. Second example here. We've got another quadratic. It's going to look like a parabola. So those points are at 0, 0, 4, 0, and 2, negative 4. Okay. And again, I got rid of those arrows, so I don't want those directions to play mind tricks with you, okay? Get this written down. This graph down. So, reading it from left to right. Left to right, it's going down, it's decreasing, and then it is increasing. Decreasing, increasing. It's decreasing to 2, and it's increasing from 2. Okay, we're dealing with the x values. Now, if we're looking at the x values, it's coming from negative infinity to 2, and then it's increasing from 2 to infinity. Okay? 2 to infinity.